Assalamu alaikum, welcome to Programming Concepts. In the previous video, we learned how to create an Android application using Android Studio and Firebase Database for IoT purposes. In this video, I'm going to move that project into next level by actually putting it into a hardware. So for this, you need some hardware components. So all you need is an ESP32 module and 5-volt relay module, some connecting wires, female to female, and a DHT11 or DHT22 module. This will be the circuit diagram. First, we're going to connect the ground pin of both the DHT and relay module to the ground of ESP32 module. Then we're going to connect the VCC from both to the 3.3 volt pin of Wi-Fi module. And then we're going to connect their signal pins, like the signal pin of relay module will be connected to D2 pin, and from DHT it will be connected to D4. And then further we can connect load to these pins of the relay module. I hope you already know how to use this relay, and if you don't know, this is the common point. So you connect the input voltage here, and then if you want to connect something that you want to normally turned off, so you connect it with the normally opened terminal. So normally opened means it is not connected, it is not closed, so the circuit is incomplete. So this common doesn't have any connection with normally opened at default state, but this common is already connected with normally closed. So that's why it is called NC, normally closed. So if you connect one wire here and the other here, then these two points are connected when relay is in default mode. But when we give it some signal, then this common and normally opened become connected, and this normally closed is disconnected. So we shall be connecting our load in such a way that when we give it a signal, it triggers and then connects the load and operates it. Okay, now we move to the coding section, so let's do it. Okay, open your Arduino IDE, and then we shall be downloading the board information. So go to preferences, and in additional board manager, put this link here. I will put this in the description. So this will help us download the ESP32 boards. And after putting it here, we go to board manager and we search for ESP32, and you will find the ESP32 by Expressive Systems. Okay, I have already downloaded it, 3.0.5 version, and if you don't have installed it already, you can download it from here. It will take some time downloading the information from boards. And then we go here, tools and boards, and then we go here, ESP32, and then we're gonna select ESP32. We can select any from here. So I'm gonna select ESP32 dev module. Okay. After selecting this, I go to examples, and here it's saying examples for ESP32 dev board. So these examples are shown according to the board selected. So you have to select ESP32 dev module. Then we need to download the Firebase library that works with ESP32. So we go to library manager. You can also open this from Sketch, include library, and manage libraries. So this will be here. This will be opened up here, and we are going to search for Firebase, and I have this Firebase ESP32 client by Mobis T. So I have installed 4.4.17, which is the latest one. So you can download it from here. Okay, after you download this, we go to File, Examples, and search for Firebase here. Here you see examples from custom libraries, Firebase ESP32 client, and then we go to authentications and legacy token authentication. Okay, here I need to write the SSID and password uh, from my router. So I will be sharing my computer's hotspot. So I'm going here, settings, and the name, which is XPS15, and the password, which is bossad1190. So I'm gonna put it here, legacy token, XPS15. Make sure the name and the password are case sensitive, so uh, there's no any mistake here. Now we need to put the database URL here and database secret here. So we go to Firebase console, open your browser, go to Firebase, then go to console, and here's the project, IoT Android. Then I go here, users and permissions. Service counts. Database secrets. And I'm going to copy this database secret and put it here. Then go back. This is the database URL. I'm going to copy it and then paste it here. Then we don't need these two variables. I'm going to remove them. Okay, now serial begin, Wi-Fi begin, and connection established. Firebase client setup. Okay, when everything is connected, we come here in the loop and we're going to put our code here in the loop. So I'm going to save this program, documents, IoT project. Okay, this new code has been saved. So we have written this program uh, so far where it can be connected to our uh, Firebase database. Now we need to write the mechanism for reading and writing the values to the database. So for this, I'm again going to examples and Firebase ESP32 client. Then we go here and select basic. And from here, uh, okay, here we need the code for reading the values. So we shall be reading uh, the fan value, which is a Boolean value. So I come here. This is for setting the Boolean value, and this is for getting the Boolean value. So Firebase get bool, this, and then this. I'm going to copy this code and create a new variable bool uh, fan switch, and I keep it false or default. Then I put the code here, Firebase get bool, and then I put my node which is IoT, and under IoT there is fan btn. Okay, when it reads the value, then we convert it and save it to fan switch. Okay, we stored this value here, and okay, we get this here. Now if fan switch is true, what we're gonna do is uh, okay, we here need to declare some pins for relay. So let's say we create an integer variable relay pin, and we set it to digital pin 2, and then we set its pin mode here, pin mode relay pin output. And as we are using the module relay, it operates the opposite. So when it is in the normal state, it on when there is no signal going to the relay module, it automatically operates. So I'm going to cancel the automatic operation, and I'm going to write the high signal relay pin high. So at the high state, it doesn't operate the load which is connected to normally opened. And when I want to operate it, I'm gonna write the digital signal for low relay pin low. Okay, when the relay pin goes low, then the normally opened switch is turned on. Else digital write relay pin high. Okay, now we need to write some values to Firebase, values for humidity and temperature, so that the Android application gets the values from the sensors. So for this, we need to include the library for DHT, include dht.h, and then we are going to specify the DHT pin, which is D4, and DHT type, which is DHT11. So you have to change these values according to your requirement. So if you're using DHT22, you have to specify it here. Then we're gonna initialize the declare the DHT instance, DHT, and DHT10, DHT type. And in the setup, we are going to begin the DHT. Then we read the value from DHT. So I'm going to read the temperature value. So float temperature, float humidity. Temperature equals DHT read temperature, and humidity equals DHT read humidity. Okay, when we get these values, we are going to write them into our Firebase server. So let's see how we can write this value. So we go here and check for setting integer. So for setting integer value, we need to use this function. I'm going to copy it and paste it here. Firebase set integer FBDO, which is the instance for Firebase data, which is defined here. FBDO, then here I'm gonna write IoT, and here I'm gonna put the name of the variable here, temperature. Temperature, and the value here, that is temperature. But my temperature is float value, and we have to provide integer here. So I'm gonna use the integer here. So what if you really have to store float variables as float values in the Firebase, because Firebase doesn't provide that. So for that, you can use post-processing and pre-processing. So for example, if I want to store the value, which is, let's say, 30.05, so what I do is I store the value on Firebase as 3005, and in the Android application I divide it back from 10. So I multiply it here with 100, so it becomes this. I store this value, and then I divide this value back to get my original value, which is 30.05. So we can use this hack to store floating point values. But for now, to keep things simple, I'm going to save the integer value. Again, I copy this and paste it here for humidity. Humidity and humidity. updating. Then I'm gonna put some little delay and save the program, auto format. Okay, I think the code is ready. I have selected the board. Let me check if the code is fine. It will take some time to compile because the libraries we use for ESP32 are usually heavier than those we use for Arduino's basic libraries. Compilation finished with some errors, unfortunately. So it says DHT doesn't name a type. Maybe I misspelled it. It is case sensitive. So let's try again. Also, the pin mode is actually pin mode here. The rest is seems to be fine. Okay, I'm going to compile it again. I'm going to pause the video and I'll be continuing when it completes. So compilation is successful. Now it's time to upload the code to the ESP32 board. Okay, now it's time to upload the code. So before connecting the ESP32 to your computer, make sure that which ports are already showing in your computer. So you can see COM4 and COM3 are already showing, and I haven't connected my ESP to my computer. So it means COM4 and COM3 definitely do not belong to my ESP32. Now I am going to connect my ESP32. So I'm going to use the USB cable, and you can see the LEDs are blinking on ESP32, and also my uh, computer played a sound that the device has been connected. Now I go to Tools, COM ports. Still, you can see the port is not showing. So maybe there's a problem with this. Let me disconnect it and connect it again. Now you see COM5 is connected. So this is definitely the port which belongs to my ESP32. So now I'm going to upload the code and it will compile it again. But this time I hope it won't take the same amount of time because it will be using the cached files. So you can see it is using cached library dependencies. You can see upload has started. And the blinking stopped on my ESP32. Now the uploading is finished, and again the blue LED is back online. Now as I told you that I'll be sharing my personal hotspot for ESP32. So now it's online, and see if the ESP32 connects with this. I go to settings, and now you would see the ESP32 appears to be connected to my computer, and also the blue LED stop. So now it's only red LED indicating that this device is connected to Wi-Fi. Now it's time to connect these components together according to the circuit diagram. So let's do this. This is DHT11, and I have connected the VCC white to the 3.3 volt pin in ESP32. Then the blue is the ground, GND. You can see the last pin, and this is connected to the GND of ESP32 below pin, and the purple one is the data pin. You can see DAT pin, the purple one, is connected to D4 as it is defined in the code. And similarly, I have connected the relay pins, input, ground, and VCC to ESP32 as the VCC goes to Vin. So Vin actually is the input voltage, so it is equal to the voltage is applied on ESP32. So as I'm connecting it using the USB, it is 5 volt. And the blue is the ground connected to GND, and the data pin which is D2 here. Okay, now I have started the application in my Android Studio using the emulator, and I have also opened this IoT real-time database page, and also I have connected my hardware. I have skipped the relay module because my fan is not that much of a load, so it can be directly operated using ESP32. So this is the power bank I have connected and powered this ESP32. So let's see what happens. So as you can see on my screen, the values for temperature and humidity are correctly fetched from the hardware. If I try to change it, like I put it 60 and press enter, and it again goes to 40, and the fan is like this. Now I try to change it from here. I think my Android Studio device is not connected because it is not showing the right values. So I go here in the rules and see what it says. So my rules has expired, so I'm going to override them. So I'm gonna put it true and true and publish. Okay, now I run my application again. Okay, now you can see it has successfully fetched the values, and I go back to data. And now if I change the value from here, so you can see the fan is operating. So as I told you that the relay works in the opposite. So when you turn it false, you have to put it in the high state, and if you want to put it on true, you have to put it in the low state. So that's why the fan is working in the reverse mode, because the relay was reversed, but this is not reversed. So it operates when it receives voltages, and it turns off when the pin is low. So if I turn it off, so the fan value becomes true and the pin becomes low and the fan stops. So this is how our project is working. I hope you enjoyed this tutorial. I will be posting another video soon, inshallah. Until then, take care. Allah Hafiz. See you in the next video.